Alright, in this lab that we're going to be doing right here, alright, it'll work out pretty good if we kind of split up a little bit. All the equipment we're going to need, I've kind of got laid out here in front of me so we can do this lab, safety goggles, all that kind of stuff. Anyway, we're going to be using a few new pieces of equipment that we ain't got to use before. But the first thing I need you to do is this. First part of the lab is going to be easy. I need somebody to get 100 milliliters distilled water. It doesn't have to be exactly 100 milliliters. We're just getting some water. You may end up with a little over 100 before you're said and done with this. But you need to get 100 milliliters distilled water, 250 milliliter beaker. So 100 milliliters distilled water, 250 milliliter beaker. So there's your step number one. Alright. Other thing, so we'll say step two. While somebody is getting the 100 milliliters of distilled water, somebody needs to go weigh out 13 grams of copper sulfate. So somebody needs to go weigh out 13 grams of copper sulfate. I'm going to pretend that that's definitely 13 grams. I feel really good about it. 13.2. 13.2, that'll work. Here's the thing, I want at least 13 grams. When y'all go to weigh, it can be more than 13 grams, but I want at least 13 grams, okay? So 13.5, even if you bumped it all the way to 14, that's fine. This is what's going to be known as our excess reactant in the lab. That means we've got more of it than we need. It's our excess. Alright, so that's going to be 13 or better. So what I'm going to do now is I'm going to heat this water. So step number 3, heat the water. Notice how I'm saying don't boil. I'm saying heat the water. So I want y'all to heat the water up that's in here. So we're going to heat the water. It's kind of like when you're making sweet tea. When do you dump in the sugar? After it's cold? When it's still warm, when it's hot. So hot liquids dissolve better. All we're trying to do is dissolve this. And 13 grams is a lot to dissolve in this water. So what we want to do to increase the solubility, we're going to heat the water up, and that should make this dissolve easier. Now I'm just going to maybe pretend this is hot. I don't have my burner lit, but we'll go. And you're probably going to see it's probably going to be a little harder to dissolve this. So I'm going to dump that in. I need a glass stirring rod. Glass stirring rod? Glass stirring rod? Glass stirring rod? Anybody got a glass stirring rod in their pocket? I promise I had one. It's a set of keys. It's not a glass stirring rod, but it is a set of keys. So we will go into this person's lab drawer and glass stirring rod. Alright, check. Why do we want to stir it with a glass stirring rod? In other words, why not just break out this nice piece of metal and give it a stir? Metal, very good. The metal will react with what's in there. So again, now the only difference is y'all should be heating this. Not boiling it. If you start to boil, just go ahead and shut the thing off and get it out of there, okay? Because all we're doing is using that is for heating it. Once you've got it hot or warm, you can stop. Now, you need to keep stirring it till you've managed to get all of this dissolved that's inside there. And it's looking like, of course, it's going to be hot when you do it, so I'll use my beaker tongs. I want to take a look at it. I've actually still got some left in the bottom. So that means I should keep heating this up. That's the big thing I don't want. I don't want y'all to have anything left still in the bottom. So that's, and I don't know that I can dissolve it since I didn't heat the water. I'll give it a little more. Get you. See what we got. I still got a little bit. So, but when y'all heat it, y'all's is going to dissolve like that. And y'all are going to dissolve more in the water than I didn't actually obviously weigh out 13 grams. Y'all are going to, when y'all do it, it's going to be a really brilliant blue. It's really pretty. Don't drink it. It will kill you. So, anyway, alright. So, while somebody is doing this, somebody else in your lab group needs to go weigh out 2 grams of iron. So, I guess this is step number 4, weigh out 2 grams of iron. Step number 1 was what? Get 100 milliliters of water. Step number 2, 13 grams of cupric sulfate. Step number 3 was heat and dissolve. Heat and dissolve for step number 3. Step number 4, 2 grams of iron. So weigh out 2. And again, it can be 2.1. I mean, I don't want you to get much more though. I want it to be like 2. Y'all, it could be even 1.8. You following me? 1.6. Really, let's make like 2.1 like a dead cutoff. Because while this one is the excess reactant, this one's going to be called the limiting reactant. In other words, this one's going to limit what we do in this reaction. So I don't want to go overboard with the iron. If you use 1.5, that's alright. You following? How about this? We just say somewhere between 1 and 2 and we'll be good. Is that even better instructions? So let's say way out between 1 and 2 grams of the iron. That's all we need. So I'm going to pretend that we've already went and we've done that. So I'm going to put me some iron in here. Got a feeling I may have messed up. That might be more than 2 grams of iron. But iron packs, you know, it's kind of heavy, so you don't have to weigh out a lot to get it. So take a wild guess what our next step is going to be. We're going to do what?
Pour the water.
Pour the water.
Pour the iron.
Pour the iron. Now this is going to be, I'm going to be very clear on this. Pour the iron in a little at a time. So I'm not going to dump it all. I'm going to pour it in a little bit at a time. Notice the water starts changing colors. What happens if you pour all the iron in at once? It will actually cause, especially if you've got the water really hot, it will basically volcano right out on top of the table. So you don't want to dump in all the iron at once. So I'm going to do a little bit more. So add all your iron. If you've done everything right, the water should still have a blue tint to it when we're done with this. So hopefully the water still has a blue tint to it. If you look, you can see now something on the bottom. Y'all, Fe plus CuSO4. What should happen in this reaction? Fe plus CuSO4. The Fe should replace the Cu. So we should now have FeSO4 plus Cu. And if you look on the bottom of this, you see red. That's copper. So we don't have iron in here anymore. The iron has been replaced with copper, and that's what's in the bottom of this. Alright, I'm going to slide this off to the side right now. While somebody is doing that, you ready? Next step? While somebody's doing that, somebody else can be doing this. Weigh a sheet of filter paper. So go weigh 1 sheet of filter paper. Matter of fact, on your data table, you'll see a place to write this down. So weigh 1 sheet of filter paper. Alright. Weigh your sheet of filter paper. Now, this is going to be kind of neat. And I hope this ain't the one that spits. One of these needs replacing. Alright, this one's good. The next thing we're going to do is set up what's known as an aspirator. If you can't spell aspirator, it's on your data table. So, but here's the thing. Aspirators suck. That's literally the way we've remembered this for like 10 years. Aspirators suck. This is an aspirator. You'll notice that one of every sink in here has one of these screwed onto the sink in here. So this is what's known as an aspirator. Do you remember in 10th grade we did something called Bernoulli's principle? We did like baseballs. I even drew a picture of a toilet on the board. And the thing was, high velocity makes a low pressure. When you turn this water on, it shoots water at a high velocity through here. That makes a low pressure inside there. That creates a vacuum. Now, if you're wondering why the little rubber floppy hose on here, it's actually for a pretty common sense thing. The reason the rubber hose is on the bottom is it keeps it from splashing all over you on the table. You take that rubber hose off, you're going to be eating water. So, this is what's going to be neat. You can actually hear the water. You can hear a vacuum. Check this out. Ta-da! So, we've got a vacuum. Matter of fact, it'll leave a hickey on your face if you do it long enough. But anyway, we've got a vacuum out of this. How do you know? How do I know it will do a hickey? Don't ask. So, here's what we're going to do. This is what's known as a filter flask. And this is, you can probably figure it out, is a funnel. Sometimes you can put a little water on your funnel and it'll help seal it up, although this sucker's jammed in there pretty doggone tight. And so what we'll do is this. I'm going to put this down into the filter flask, And this is what's called a filter flask. I'm going to hook it to the aspirator. If you try to filter without this vacuum, this lab would take an hour to filter. This thing right here is going to literally suck the water through this thing. It speeds up the lab like crazy. You take organic in college, you're going to do plenty of this. This is what's known as vacuum filtration. So what we're going to do is this. So what have I already supposed to have done to the filter paper? Should have weighed it. So I've already weighed it. Now I'm going to take it, and this is how you fold a piece of filter paper. Are you ready? Like Houdini. I'm going to fold it over. Da, da, da. Whoa. You like that? Now fold it again, and now make a little fan out of it. You good so far? So fold it again. Now check this out. Magic time. Open it up, and you got like what looks like a little funnel. Hopefully it's not a funnel. We want it to be a sealed piece of paper. I'm going to take this piece of paper, which I've already weighed. I'm going to put it down in here. Now it don't fit very well down in there. It's kind of loose and got air gaps. So I'm going to take some of the distilled water, and I'm just going to do this and kind of wet it. And you'll actually see, I'll go ahead and fill it up just for show and tell. And it's dripping through there, and it's going pretty fast, but check this out. And gone. Just like that. So are you starting to see why we do the filter? Although I'm going to warn you on something. If you whack this thing up a little too high, you can hear the air going through that, can't you? If you turn it up too high, you will suck the bottom out of that filter paper, and then you're going to be doing this lab over again. So do not get crazy on your filtering, okay? You want it to go, but you don't want to get crazy. Now, so here's what I'm going to do next. I'm going to now turn the water on. I'm even going to listen. My filter paper, I've pulled a little bit too much vacuum. I like taking my finger and really just kind of setting the filter paper. I want it to be tight in there. And I'm going to start doing this. And this is where some people mess up. They swash. They like slosh this around. I want the copper to kind of set on the bottom. Because I want to do this. I want to just pour the liquid off. Some people call this decanting. And you're seeing just how fast this lab can be done right now. And what I've done is I've got a little air pocket in there. There we go. Did you hear how it's Did you hear that? That's because it was sucking air down. That takes it slower to funnel. Remember what I said about sucking the bottom out of the filter paper? Yeah, I kind of just did that. So, oh no, I screwed up the lab. We're going to pretend that didn't happen. But the problem is, hey, let's go get some filter paper because I didn't have any more. You ready? Follow me, guys. Say hello to my class. The only reason I'm saying this is we might put this on YouTube. 14.6. This is what we call the man cave. Nothing against Womans. Matter of fact, I kind of like the Womans. But anyway, this is the inner man cave. Man cave sanctuary. Box of filter paper. Now we're good. I should probably be talking, it'd be more entertaining, but here we go. I'm going to get some more filter paper. Now, so what did we learn just now?
Got this.
Don't turn the vacuum up too high, or you could suck the bottom of the filter paper. My problem is I'm in a rush. Hey, do you remember how to fold this?
Yeah, half.
Half it. Woo! And now,
Another half.
fold it over again. And then we will tuck and open this, put it in there. Take a little water. Sit down in here. I'm going to blame Hunter for this. That's probably what happened.
That's
Cameraman's fault.
Yeah, that's me.
Alright, I'm going to turn this liquid on. Not as much. Y'all, this is what's going to take you some time. This is where, really, I can't rush this for the video. I'm going to have to cheat. But you're going to have to pour a little off, vacuum it, pull it through, pour it off. Don't fill it over the top of the filter paper. That's a goof up. So, but you're going to have to sit here and do this. And then, watch it go, watch it go, watch it. Don't watch this part.
So entertaining.
Oh, look, we're almost done with it. So we'll finish pouring that. This is getting exciting. Oh, I'm going to get greedy and end up knocking a hole in it again. It's alright, I'm actually just about there. What I'm trying to do is get the copper isolated in the very bottom of this. And I feel like, I don't know how good a reaction I did. I might should have stirred this a little bit more when I was doing the reaction. I probably should have. Matter of fact, I got a feeling I might have messed up a little, so I'm going to add a little solution back. Now, the bad thing is this is slowing me down, but the water should still be blue. Yeah, I should have stirred this more after I added the iron. I should have stirred this more. Now, the problem is I've got some copper stuck to this. That's no big deal. I can just squirt that off and get the copper off of it. So, but you do need to stir after. Don't just dump in the iron and leave it. This ain't the Ronco set it and forget it commercial here. When you dump in the iron, you still need to stir. And I got a feeling I've got some unreacted iron in this. But we're going to pour this in. And a matter of fact, I did just really make my product look better. Probably getting a little bit greedy right now. Matter of fact, I better watch it because I'm going to rip this paper out. When you start hearing that, yeah, that could be bad. So I'm going to try and not get carried away. I'm going to keep pouring this off. Eventually I want to get all the liquid poured off. So eventually I should get all the liquid, and look at what we're left with. Beautiful copper. Look at the copper.
It doesn't look very beautiful.
It's kind of beautiful. Anyway, now this is what's neat. I can get this copper out in almost one single thing. I'm going to tilt it up and take this little squirt bottle and check this out. Bam. All the copper's out. And now, I don't want to rush at this point. I'm not going to turn the vacuum up and chance ripping it out. What happens, the copper stops up the filter paper. And when that happens, it's like, point in the lab. So, I'm going to let this part, that's why I try and filter as much liquid off as I can before I get the copper out. That's why I don't want to like slosh it around. I want to set it just a little bit before I do it. Yeah, you're on YouTube. Okay.
Hey, I'll be done at the computer light.
Alright, so filter. Alright. And I think we're about done. This is what it looks like down in the bottom. So now we're going to take this out. Theoretically, a pair of tweezers would probably be better, but it's pretty much just copper. So I'm going to reach in. Be careful, you will tear the filter paper. But once you've done this, there's your copper. That's what we want. Follow me. This is still damp, so guess what we want to do to it? We want to dry it. So to dry it, we're going to come over here to the lab oven. Now, I'm not going to have the oven turned up very hot. Matter of fact, somebody's cooked the pizza in here. But anyway, what I want you to do is each lab group, find you a place in the oven where you know it's yours. Theoretically, you should put a number on the filter paper before you did this lab or something. That might help. But anyway, I'm going to lay the filter paper in the oven. Shut the oven. Now, Monday you're going to have one more thing to do in this lab. You're going to have to do one more thing Monday. Any guess what it's going to be? You need to weigh that again Monday. So after it's dried out, you need to weigh it again. So, has everybody got it? Step number 1, 100 milliliters of water in a 250 milliliter beaker. Step number 2, 13 grams or extra cupric sulfate. Step number 3, heat the water, dissolve the cupric sulfate. Step 4, weigh out between 1 and 2 grams of iron. and then dump that into, what did I not do that I should have done? After you dump in the iron, stir it up. Be careful of your glass rod though. Make sure you squirt everything off of it when you're done. Alright, stir it up. While somebody's doing that, somebody can set up the aspirator. Set up the aspirator. Filter paper needs to be weighed and folded, put in the thing. Then all you got to do is filter everything off. Filter paper goes where? In the oven. Monday you got one more step. What'll that be? Hey, I'll be honest, if you get a chance, it'll be done before 6th period. Some of you have got me 7th period. If you want to come on in here 7th period and just go back and go ahead and weigh it, you can be done with this lab already. Really, there's no need of waiting till Monday. It'll be done by lunchtime. It'll already be dried out. So, anyway, that is the lab. The extra cupric sulfate, I'll have a waste container setting here. Pour all that extra blue liquid out inside this thing, alright? And then I'll dispose of that later. Alright, any questions? Make sure we wear our safety goggles. And remember, I love you guys.